day to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on calculus of variations, lecture number 7, in which I will derive the geodesic on a sphere. Now, we solve the problem. Problem is, prove that the shortest distance between 2 points on a sphere is the arc of the great circle joining them, or find the geodesics on a sphere. Now we solve this. Let O be the center of a sphere with radius equal to r. Let we consider O to be the origin. Let P x, y, z be a point on the sphere. Therefore, OP equal to R. Let theta be the angle between OP and Z axis. Let us draw PN perpendicular to Z axis. Therefore, ON equal to OP cos theta, ON equal to Z, Z equal to OP equal to R cos theta. And this is number 1. Let us draw PM perpendicular to XY plane. Let us join OM. This is theta. Then this angle will be pi by 2 minus theta. Therefore, OM equal to R sin theta. Let this angle means MOQ equal to phi. Now let AMQ perpendicular to x axis implies that this is phi. OQ equal to OM cos phi implies that OQ be x equal to OM. Let this is number 2. OM be R sin theta and this is cos phi. This is number 3. Let MR perpendicular to y axis. Therefore, OR equal to OM Sin phi, ORBY, OMB, R sin theta, and this is sin phi. This is number 4. Therefore, from 1, 3 and 4, we get x equal to R sin theta cos phi, y equal to R sin theta sin phi, and z equal to R cos theta. Let this equation be 5. Since radius of sphere equal to R, therefore x square plus y square plus z square equal to R square. This is number 6. Let ds be an elementary arc on the sphere. Therefore, ds square equal to dx square plus dy square plus dz square. Let this is number 7. From 5 we get dx equal to R is constant, d of sin theta is cos theta, d theta, and cos phi constant, plus R sin theta constant, d of cos phi is minus sin phi, d phi, dy equal to R constant, d of sin theta is cos theta, d theta, sin phi remains constant, plus R sin theta, d of sin phi is cos phi, d phi, dz equal to R minus sin theta, d theta. Now dx square plus dy square equal to R square cos square theta cos square phi d theta square plus R square sin square theta sin square phi d phi square minus 2 R square cos theta sin theta cos phi sin phi d theta d phi, this is dx square plus dy square R square cos square theta sin square phi d theta square plus R square sin square theta cos square phi d phi square plus 2 R square cos theta sin theta cos phi sin phi d theta d phi. Here we see that this is minus and this is plus. Cancel. This cancel from this and this term. R square cos square theta d theta square common remains cos square phi plus sin square phi plus from this and this term we take common r square sin square theta d phi square. R square sin square theta d phi square remains sin square phi plus cos square phi. This equal to r square cos square theta d theta square. This is 1 cos square phi plus sin square phi plus r square sin square theta d phi square, and this is 1. Therefore dx square plus dy square equal to r square cos square theta d theta square plus r square sin square theta d phi square. This is number 8. Now dx square plus dy square plus dz square, this equal to, first we write this r square cos square theta d theta square plus r square sin square theta d phi square plus dz square is r square sin square theta d theta square, r square sin square theta d theta square. Here we take common r square d theta square. Here remains cos square theta plus sin square theta, and here r square sin square theta d phi square. This is equal to r square d theta square. This is 1. This is r square sin square theta d phi square, and this is equal to ds square. Implies that we divide both sides by d theta square. ds by d theta square equal to r square plus here r square sin square theta d phi by d theta square. Implies that ds by d theta equal to, we take common r square and square root, so outside r square root 1 plus sin square theta d phi by d theta is phi prime square. Implies that ds equal to r square root 1 plus sin square theta phi prime square d theta. Let this is number 9. Let s equal to arc length joining 2 points A and B on the sphere. Therefore, integrating 9, we get integration point A to B ds equal to integration point A to B r square root 1 plus sine square theta phi prime square d theta, implies that this is S r outside integration A to B square root 1 plus sine square theta phi prime square d theta. Let this is number 10. Let square root 1 plus sine square theta phi prime square equal to, here we see the quantities theta and phi prime. So we write this function of theta and phi prime. Let this is number 11. Therefore, 10 may be written as S equal to R integration A to B F theta phi prime d theta. This is 12. For the maximum value of S, the quantity I equal to integration A to B F theta phi prime d theta will be maximum. Because R is a constant quantity. Let this is number 13. For this, Euler-Lagrange condition will be partial derivative of f with respect to phi minus d by d theta, partial derivative of f with respect to phi prime equal to 0, implies that f does not contain phi in 11. So this will be 0 minus d by d theta, partial derivative of f with respect to phi prime equal to 0, since from 11 f does not contain phi explicitly, implies that if we integrate this, partial derivative of f with respect to phi prime equal to constant C. Let this is number 14, implies that partial derivative with respect to phi prime, value of f is square root 1 plus sine square theta phi prime square, and this is equal to C, constant. Implies that this is 1 by 2 square root 1 plus sine square theta phi prime square multiply sine square theta multiply 2 phi prime, and this equal to C. Here 2 cancel. Let this is equal to sine alpha. Alpha equal to constant. Squaring both sides. We get sine to the power 4 theta phi prime square by 1 plus sine square theta phi prime square equal to sine square alpha. Implies that sine to the power 4 theta phi prime square equal to sine square alpha 1 plus sine square theta phi prime square. Implies that sine to the power 4 theta phi prime square equal to sine square alpha plus sine square alpha sine square theta phi prime square. We take this left side. Implies that in left side if we take this, we take common sine square theta phi prime square. Here remains sine square theta minus sine square alpha, and right side sine square alpha. Implies that here phi prime square left side and right side sine square alpha by sine square theta multiply sine square theta minus sine square alpha. Implies that phi prime equal to here sine alpha taking square root both sides. Here sine square theta means sine theta square root, and this square root sine square theta minus sine square alpha. Implies that d phi by d theta equal to sine alpha by sine theta square root sine square theta minus sine square alpha. Implies that d phi equal to sine alpha by sine theta square root sine square theta minus sine square alpha d theta. Integrating we get here remains phi. Let we take a constant beta equal to integration sine alpha by sine theta square root sine square theta minus sine square alpha and d theta. Beta equal to constant. Since sine alpha is constant, so we take this outside. sine alpha integration here d theta by sine theta here square root sine square theta minus sine square alpha. This is number 15. Let I equal to integration d theta by sine theta square root sine square theta minus sine square alpha. Let this is number 16. Now let tan theta equal to 1 by u implies that sec square theta d theta equal to minus 1 by u square du implies that sec square theta is 1 plus tan square theta d theta equal to minus 1 by u square du. This is 1 plus 1 by u square d theta equal to minus 1 by u square du implies that 1 plus u square by u square d theta equal to minus 1 by u square du implies that u square cancel d theta equal to minus 1 by 1 plus u square du. Let this is number 17. Now sin theta equal to tan theta by square root 1 plus tan square theta, because tan theta equal to sin theta by cos theta and square root 1 plus tan square theta is sec theta. So sec theta equal to 1 by cos theta cancel, remains only tan theta equal to 1 by u by square root 1 plus 1 by u square implies that sin theta equal to, here if we take LCM, u square, here 1 plus u square, square root of u square is u cancel, so this remains 1 by square root 1 plus u square. This is number 18. Using 17 and 18 in 16 we get I equal to, here d theta equal to minus 1 by 1 plus u square du, here sin theta, this is integration, sin theta means 1 by square root 1 plus u square root sin square theta means 1 by 1 plus u square whole square sin square theta minus sin square alpha, and this will be equal to integration, here square root 1 plus u square, here we take this outside and remains minus du by, here 1 minus 1 plus u square sin square alpha and square root. This equal to minus integration du, here 1 minus sin square alpha minus u square sine square alpha and square root. This equal to minus integration du 1 minus sine square alpha is cos square alpha minus u square sine square alpha square root. Let this is number 19. We may write left side I means here integration d theta by sin theta square root sin square theta minus sin square alpha, and this is equal to this quantity. This is 19. Using 19 in 15, we get 5 plus beta equal to sin alpha here, and value of this is, here we have minus, so we write here minus integration du by square root cos square alpha minus u square sin square alpha. This is equal to minus sin alpha integration. Here we take common cos square alpha 1 minus u square sin square alpha by cos square alpha. This equal to minus sin alpha integration. We take this outside du by cos alpha, here square root 1 minus u square tan square alpha. Here sin alpha by cos alpha is tan alpha minus, since alpha is constant, so we may take this outside. So here tan alpha integration du by square root 1 minus u square tan square alpha equal to minus, we may take this inside tan alpha du by square root 1 minus u square tan square alpha, implies that minus integration, we may write this du tan alpha by square root 1 minus u square tan square alpha, since alpha equal to constant, implies that phi plus beta equal to, we may write this cos inverse u tan alpha, because integration of minus 1 by square root 1 minus x square equal to cos inverse x. This is implies that cos phi plus beta equal to u tan alpha, implies that cos a plus b formula, cos phi into cos beta minus sin phi into sin beta U means 1 by tan theta, tan alpha, implies that cos phi cos beta minus sin phi minus sin phi sin beta, this is tan theta means right side here cos theta by sin theta, this is tan alpha, implies that sin theta cos phi cos beta minus sin theta sin phi sin beta equal to cos theta tan alpha. We multiply both sides by r sin theta cos phi cos beta minus r sin theta sin phi sin beta equal to r cos theta tan alpha, and this is equal to x cos beta, this is minus, this is y sin beta, and this is z tan alpha, implies that ax plus by equal to cz. Here cos beta equal to a minus sin beta equal to b, tan alpha equal to c. This is equation 20. Equation 20 is an equation of a plane passing through the origin that is passing through the center of the sphere. Let this plane is denoted by pi, since the arc AB lies on the plane as well as on the sphere. Therefore, the arc AB is the intersection of the plane and sphere. Therefore, the arc AB is an arc of a great circle, because the great circle is a circle on the sphere whose center is the center of the sphere, that is the origin. So the geodesic is an arc of a great circle of a sphere. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.